Today we have with us Dr. Srinivas Reddy. The topic is going to cover is energy conservation through solar energy technologies for industrial process and heat applications. Prior to that, I would like to give his brief introduction. Dr. K. Srinivas Reddy obtained his PhD from Indian Institute of Technology, Delhi in Energy Studies in 1999. He then joined National Institute of Technology, Warangal in June 1999. After a brief service of about 4 years at NITW, he joined IIT Madras in April 2003 as an assistant professor. Presently, Dr. Reddy is Professor of Mechanical Engineering at IIT Madras and is also an honorary professor at University of Exeter, UK. He also served as an adjunct professor at CEERI CSIR Chennai during 2014 to 17. Professor Reddy is a fellow of National Academy of Engineering and he is a specialist in renewable energy with special research interest on concentrating solar power energy efficiency and environment. He has 9 patents, 4 granted applications, and more than 280 applications with more than 6,000 citations and H index of 43, of which 160 papers in reputed international journals, including 5 review articles on solar energy systems and energy storage. His co-authored book on sustainable energy and environment, a clean technology approach, published by Springer, and book chapters on solar energy systems are popular among energy and environment community. Professor Reddy is actually involved in implementation of solar thermal technologies of power generation and process heat applications through design, development, demonstration, deployment (4D) approach. He has secured research funding about $50 million as principal investigator and co-PI of more than 30 research projects related to solar energy, energy and environment, and heat transfer areas, supported by various Indian and foreign funding agencies like DST, CSIR, AICT, RCUK, IGCS, ICI Impact, etc. His work on estimation of thermal conductivity and thermal physical properties and characterization of engineering materials significantly benefited the industrial associates for development of energy efficient insulation material. As a part of human research development activities, he supervised over 200 UG, PG, and PhD students. Most of them are now well placed and working now in prestigious organizations. He has organized several national and international workshops on advanced renewable energy technologies. So, with this brief introduction, I would like to hand over the session to Professor Reddy, sir. Please, sir.
Yeah, good afternoon to everybody. Can you see my slides?
Yes, sir. Yes.
Okay, perfect. And if you have any problem, please let me know. In case if it gets disconnected, sometimes this net is highly unstable. Good afternoon to everyone, and of course, this is very hard slot during lunchtime. So I hope you will bear with me. Anyhow, since it's online, we can manage. At the outset, I thank the organizers for giving me an opportunity to give a talk in this AICT Training and Learning Academy sponsored staff development program on energy conservation and energy management. This is a very important. Energy generation is very important, and also energy conservation. Sometimes we conserving energy is as good as producing energy. So therefore, it's important to conserve energy and also manage the energy through proper energy management. So I'm going to give a talk how the solar energy technologies play an important role mainly in industrial process heat applications for energy conservation, because how do we save energy, and energy conservation in the sense it's effective utilization of energy in the industrial sector. So I'm going to give some important industrial processes where the heat is involved and where the heat requirement is fulfilled by fossil sources, but they are not sustainable. So therefore, it's important to come up with conservation methods and also substitution of renewable energy into these I'm going to emphasize some of the technologies which are mainly used for industrial process heat applications and for wide ranges of industrial process heats. So I'll give you quickly because this course program is on energy conservation and energy management. So it's important how important to discuss how energy is very, very important. So energy, there are several problems and we are facing for a couple of decades. And energy, water, food, environment, poverty, terrorism, war, diseases, education, democracy, population. Energy is the most important because now we are using, exploiting it because without energy we cannot live. It's a driving force for the universe. So therefore, we need to address this energy in an appropriate way so that the energy production and utilization is in a more sustainable way. But what we are doing not presently is we are utilizing the energy from the fossil fuel sources. But so therefore we cannot address the problem of energy standalone. So therefore energy and environment they go together. So energy, clean energy, water, food are the major concerns now for the present society. So therefore energy plays a major important role in solve most of the problems. And world's energy consumption is rapidly increasing. So therefore, if you look at the fossil fuel sector, it's oil, coal, and gas are the important sectors which play important role for in fulfilling the uh, energy needs. Apart from that, we have other sources like hydroelectric, renewables, and so on. The energy is one of the important parameter. If you look at the per capita energy consumption, that indicates the standard of living of an individual country or an individual family or an individual person. So if you look at the per capita energy consumption as far as India is concerned, it's much lower than the world's average. Not only world's average is the highest other developing countries and even our neighboring countries is important. So if you look at what are the energy sources, the energy sources may be grouped into two categories. One is celestial or income energy, celestial or income energy. That means this celestial income energy means the energy which is reaching to the earth from outer surface is called celestial or income energy. So this includes solar energy. Of course, whatever comes from outer space is solar, lunar, electromagnetic, gravitational, particle energy from stars, planets, and moon, and potential energy of meteorites entering into the Earth's atmosphere. The capital energy is the energy which already exists in and on the Earth, mainly geothermal, atomic energy, which is a fossil fuel energy source. These are the capital. So whatever is we are using presently is a capital energy here, mainly in the form of chemical uh, form. So that is a fossil fuel or oil gas. But there are apart from this, nuclear and geothermal also comes from the Earth's crust. So therefore, this is called capital, which is already existing in the Earth. But whereas the celestial or income energy, which comes from the outside space, but generally what we look at mainly is the solar and lunar energies are major renewable energy, which we call them as a renewable, and which should play an important role as far as our energy needs are concerned. But of course, there are other forces which we may have to. Now it's very difficult to exploit this energy with the present technology. If you see the energy reserves, there are four classifications. One is renewable or non-depletable energy sources. That includes all renewable energies, coal, solar, wind, biomass, ocean. Fossil fuels are coal, oil, gas, which we are almost 70 to 80% we are utilizing. And nuclear energy is also another important aspect, but across the world there is a less importance on nuclear energy because most of the European countries mainly which they are these countries, some of these countries are, I think, that they are highly dependent on nuclear, especially France and other countries. They are now, even Germany and other countries, they are now reducing the dependency on nuclear and they want to phase out nuclear energy in near future. future. But I think we have to look at in India also not many nuclear power plants are coming up. But if this fusionable isotope we are talking about ITER, that is activity where fusion plays a major role, and if it comes, it will be a great solution for nuclear. And if you look at the nuclear energy, how we in the energy system, how do we convert into other forms of energy? We have uh, uh, we have energy sources, which includes fossil fuel, coal, oil, gas, and nuclear and renewables, and they are transformed into secondary energy sources like liquid fuels and electricity, energy carriers, and then subsequently transformed into utility, whether it's a mobility or buildings, and depending upon the requirements and consumer choice. So therefore, it is important to have the energy system, because see here the energy carriers plays an important role, because the electricity, yeah, and the liquid fuels like petrol and diesel, and apart from that the hydrogen are the mainly these are the energy carriers. They are not the sources. So these energy carriers like electricity is transformed from one to another location, and converting one form to the another form. But electricity needs to be utilized or used in real time rather than the storing. Storage cost is very expensive nowadays because battery storage and so on. So therefore, every level of these conversion processes involve energy losses, and what you call irreversibility. That is why this course is on energy conservation and energy management. So at every level, we need to have energy conservation and energy management. At every level means at the source level, at the carrier level, at the equipment level. So therefore, end-to-end solutions are required for energy management and energy conservation, so that the overall energy utilization will be very effective. So if you look at this process, if you energy conservation and management, if you can do it through renewable energy, it's a better option because of economics point of view, as well as the overall environmental point of view also. So if you look at that, the world's energy consumption is this, and this is a small tiny circle. This is about 16 terawatts, but this is being met by coal, uranium, oil, natural gas, wind, biomass, hydro, geothermal, wave, tidal, and so on. And the bigger circle, which is in yellowish color, is the solar, and which has a huge potential as far as the requirement. So when these sources supply to these world's energy consumption, obviously they deteriorate over a period of time, or they deplete over a period of time, and then they become extinct. So therefore, I'm not only these fossil fuels exhausting the fossil fuels, but also these fossil fuels are highly responsible for global climate change and environmental issues. So therefore, it's very important, and across the world, it is decided that we have to phase out these, and not only that, but also we are talking about net zero energy targets, and by India is targeting about 2070, we want to go for uh, uh, net zero emission, net zero power, net zero energy targets. So therefore, eventually the renewable energy plays a major role in this case. And this demand and prosperity dependent on supply and source, energy demand and energy utilization depends on availability of energy as well. So if you have more energy, hello, can you hear me? Hello, hello.
Yes, sir.
Okay, because something I heard some sound, so therefore I thought it's this time.
Okay.
Yeah, because I cannot see what is happening at the back. Only I can see the slides. Okay, thank you very much. See, energy demand and prosperity, wherever we have more energy demand, more energy, because these fossil fuels resources are not distributed evenly across the world. But some locations there are some resources are excessively available. Some places they are deprived of these resources. So therefore, it's important to utilize them. And again, wherever the energy demand is there, there is energy prosperity. So therefore, more energy, more this thing. So this is shown in terms of the night lights and so on. But still, there is a lot of darkness or uneven illumination of that. That is because of energy poverty uh, here. So there are in several countries still the people are competing for energy and mainly both primary and secondary forms of energy. Still, several million people are dependent on biomass as the fuel for cooking applications. Not only that, but also the improper grid, improper supply of electricity also plays a major role. As far as this location is concerned, there are a lot of certain people do not have access to the electricity. They do not have availability of proper energy. Still, they are dependent on biomass, as I mentioned. The basic requirement for human survival is food, water, and air. So air is somehow is available free of cost, but it's highly polluted. Water is not available. Most of the water bodies are polluted. And then, of course, the food we have to buy. So therefore, food, the basic food processing is cooking, and still many people are dependent on conventional biomass for cooking energy requirements. So therefore, it is very important and to utilize, come up with a clean energy solutions for even basic requirements. Then only we'll be able to uh, uh, take care of our requirements. But unfortunately, what happens is uh, the the sources are unevenly distributed. Somewhere you have more resources, somewhere there are less resources. So therefore, the energy sustainability is very important. And this energy sustainability, we feel that we need luxurious automobiles, which requires fuel as well as the basic infrastructures. So we import the coal. If you have money, you can buy that and use it. But if there's no fuel, what will we do with this type of luxurious car? So because we import coal, oil, gas from abroad, and mainly the coal is from Indonesia, Australia, and South Africa. Oil is from the Middle East. So in future, if there is any shortage of these fuels, obviously it will result into unsustainable solutions of energy. So therefore, if you don't get oil, then we have to land into this kind of situation. So therefore, it's very important to have energy sustainability. Energy sustainability will also be associated with environmental sustainability. So if you look at the bluish color, and it is surrounded by the atmospheric air, and this atmospheric air is the energy, excessive energy consumption, and that's why we are looking at energy conservation and management in every aspect. So therefore, this atmospheric air around the Earth is completely polluted with excessive emissions of greenhouse gases and greenhouse gases, but also the particulate matter and other environmentally polluting gases, which whose concentrations are beyond the limits or beyond the tolerable limit. As we excessively emit the pollutants into the atmosphere, obviously the atmosphere gets imbalanced, and that's why we are talking about global climate change and so on. So therefore, that means we are literally over polluting the Earth's atmosphere. That's why we are talking about this unusual weather variations and unusual weather prevailing weather conditions, and which may result in either somewhere you have more waters, more rains, some other location, the drought area. So therefore, there are a lot of global climatic issues. So any overloaded system, it looks like this. If we put too much pollutants into the Earth's atmosphere, obviously the atmosphere is unconducive. See, every day you can see that the pollution levels in the atmosphere in every city. You can see when weather conditions. So obviously these systems are getting polluted too much, and especially the mainly metro cities like the Delhi and other metro cities, you can see that. So therefore, it's very important to come up with a energy conservation and energy management that can be done through renewable energy in a more sustainable way. These resources needs to be uh, utilized in a more sustainable way. That means for that making resources sustainable, you need a technology. If there is no technology, what happens is these resources are limited and they extinct as we consume. So therefore, only technology can the resources for the future generation. So it's easy to use fossil fuels and exhaust them, and then future in another 100 years you will left with no fuel, so that the future generation have to strive or struggle for their energy needs. Unless you make them more sustainable, then the future generation cannot survive or cannot be alive. So therefore, it's very important to have energy sustainability through technology development. So therefore, we need to develop a technology which keeps the resources for the future generation, and so that we can utilize the resources as per our requirement. So therefore, it is important that there's only one earth we have to take care of. So please take care. So therefore, energy sustainability is very important. How do we achieve this energy sustainability is important, and these there are several methods by which we can attain the sustainability. The first one is energy efficiency. What we are talking about, energy conservation, where utilizing the energy most effective way. Then going for proper mix of energy sources, because there is no single source or single solution is possible to meet the energy requirement. So therefore, we need to go for a judicious mix of various renewable and non-renewable energy sources in order to meet the demand. Of course, in a longer term, we are talking about 2070, another 50 years from now. Of course, we have to make it a zero emission, so net zero emissions. So therefore, the only way one can achieve is going for renewable energy technologies. So therefore, it's very important to look at the barriers to bridge the welfare gap, mainly in order to achieve the renewable energy system or energy supplies. So if these energy supplies are predominantly governed by various other barriers, that includes transportation bottlenecks, because as I mentioned that these resources are not constant, not uniformly distributed. We are importing oil from Middle East, so therefore it is transported through the ships and pipelines and so on. So when there is a problem in supply of these uh, containers or the tankers and so on, then there is a transportation bottlenecks, because it has to transport from one end to the other, because we are talking about say, import oil. Earlier we used to import oil from Iran. Now there are international sanctions. Because of that, they are unable to import. So therefore, there is a transportation bottlenecks, and sometimes the demand is increasing highly rapidly, because as I mentioned that the standard of living of India per capita is increasing per person, and also per capita energy consumption as well as the uh, income is increasing rapidly. So therefore, the increasing energy demand, and which results in the gap between demand and supply in domestic, and because the domestic supplies can only give 30%, 40%, remaining 60-70% of the oil we are importing. So therefore, there is a huge domestic unrest in that. And then the energy investments, because we need to spend, for example, electrical energy. Every megawatt we want to produce electrical energy, it requires 5 to 6 crores of rupees for capital, but another 5 to 6 crores of money is required for transmitting from one end to another, from the source to the utilization. So therefore, there is a huge investment is required as far as the energy sector is concerned. And then market deregulations. The market is, you know, that the petrol prices earlier used to change every day. So therefore, there is a market deregulation of these energy supplies. And apart from that, the energy price volatility, because to the prices are internationally going up and down depending upon the generally it's not up and down, it's only up. The increases rapidly, so therefore the energy prices are highly volatile. Today is something, tomorrow is something else. But then it's important to come up with that technology development. Unless you come up with your, see, now we are talking about EV, electric vehicles, so that our oil dependency is reduced substantial. The other one is a geopolitical instability. That means, see, there are geopolitical things. If you see there is a unrest among the among countries, mainly developed countries and developed countries, because of the oil being a kind of commodity which is essential for the entire world. So therefore, wherever is the oil which is there, there obviously there is a force, there is an unrest there. So therefore, that is a instability plays a major role. And of course, then as far as India is concerned, we are importing large amount of energy sources, uh, uh, and it is increasing because of the short supply of the domestic uh, problems. So how to what is energy security? How do we attain this energy security? The energy security is nothing but it is a supply, continuous and uninterrupted availability of energy to a specific country or region. See, if we, energy security for India is very important. But otherwise, what happens is, suppose if all of a sudden the Middle East stops fuel, then how do we, uh, how our automobiles go forward? So therefore, it is an uninterrupted, continuous availability of energy to any country is called energy security. The security of energy supply conducts a crucial role in decisions that are related to the formulation of energy policies strategies. So then the energy supply, how much energy is there, and in next month how much we need to import. These strategies are very important in order to make it this supply highly reliable. The, and it also treats the energy security can also be due to natural threats. These are threats are there. These threats can be either natural or technological or human based threats, which may lead to disruption because there is a discontinuous of the fuels. So disruption or damage of the energy systems. Then how do we stabilize the greenhouse gases? How to conserve energy in a cleanest way, and how to come up with the management? So there's no single technology that can do it for all, and it is because the technology different from region to region. See, in Tamil Nadu you have different, in Gujarat you have something else. So therefore, it is different for regions, different for markets, scale up requirements, infrastructures, technology dynamics, and preferences and resources. So if you look at, these are the factors which plays an important role in vehicles, energy efficiency, biofuels, hydrogen fuel, and net zero emission buildings, industrial process heat, or another important nuclear power can stabilize some of the greenhouses. And of course, the carbon sequestration, mainly, carbon capture and sequestration, capture and store it is now we have to implement new methods by for capturing the CO2, which are CO2 emissions may come out of the fossil fuel burn. Apart from that, the advanced grid technologies, because we need to transport, as I mentioned earlier, that the power plant. See, we get now you may be getting energy from Chennai or from even Bhutan or some other location, now neighboring country, because this electricity is produced somewhere else and it can be transmitted to a longer distances. So in this transmission, what happens is there is huge losses involved. Energy conservation is a plays an important role in this case. So because the losses, transmission distribution losses are about 40%. So therefore, it's very important to minimize these losses through advanced power grids. So therefore, it's important to come up with the advanced power grid and also utilizing the fuels and biomass power. And then apart from these, other renewables like solar, wind, and other renewables can be used so that this comprehensive approach can also minimize the greenhouse gases or stabilize the greenhouse gases even by 2070 or so, because our requirements are high and highly diversified countries utilizing the various resources. Their grades, energy reserves are these, because I have already explained to you the world's energy consumption is so tiny, and but these are being supplied by this requirement is being supplied by coal, oil, gas, and then we have abundant solar energy at the top. And if you look at these, the approximate lifestyle of the energy in years. So if you look at Indian oil can only go for up to 21 years. After that, there may not be very, or there may not be any oil, or there may be any. There is a possibility of extinction of these oil reserves. And of course, if you look at these, only we are good at coal. We have abundant coal, and this coal being used for industrial processing and so on. So it is very important that we need to depend only on future energy sources like renewable energy. And most of the Indian energy consumption is primarily dependent on how we use it, whether we use in the form of heat or we use in the form of electricity. If you try to use, and of course, electricity is the uh, most efficient or more high end use efficiency source or carrier. So electricity is the most efficient energy. Why? Because the electrical energy can be converted into other forms of energy with 100% efficiency, whereas other sources cannot be converted into electricity with 100% efficiency. So it is the difference between heat and energy. Energy can be completely converted into heat, whereas the reverse is not possible. You cannot completely convert heat into electricity. So therefore, when we try to convert heat into electricity, obviously it is 30% efficiency only. So remaining 70% you are rejecting heat into the atmosphere. When you converting electricity, and then that electricity if you use for heating, there is no use. So therefore, it's important to use heat as it is, which we call as process heat, and the other one is the power generation, where we use electricity directly. So if you look at this uh, utilization of heat, we can use this heat either for power generation, which is about 60 greater than 60 degrees Celsius, or process heat, which is less than 260 degrees. So in less than 260 degrees, we have a very wide variety of applications like water heating, cooking, drying of foods, refrigeration, distillation, and so on. The other way we may have to use for electricity generation through various cycles. And some of you know very well, as per thermodynamics, as I mentioned, that the heat is a low quality commodity, low quality heat, a low quality energy, whereas the work is high quality energy. As I mentioned, that the one can be completely converted into another form, but whereas the other one cannot be completely converted, like heat cannot be completely, so they're converted into electricity. So therefore, there are several cycles like Rankine, Stirling, and Brayton cycles which are used. So therefore, the most industrial processes use heat, and in fact in India, the total primary energy, whatever is used by all of us, and more two-thirds of the industrial process heat is from the energy consumption is to the process heat. So therefore, there is a tremendous scope for industrial process heat, and this is important for industrial applications. That depends on the main temperature of the processes. I have listed out several processes which involve uh, process heats. That includes sterilizing, hydrolysis, then pasteurization, drying, distillation, evaporation, washing, cleaning, and polymerization. So these are various processes in which the industrial heat is used. So therefore, there are commonalities, of course, to allow them grouped into these categories. One is fluid heating, then calcining, then drying, then curing, and farming. There are, of course, other process heat applications also. These process heat applications are listed here, and you can see how many out of these five process heats. There are other sub classifications which involve various industrial processes. Here, you can see that air heating, mainly fluid heating. You have so many other options. Then calcining is mainly used for high grade process heats like cement, coke, and calcining and mineral, of course, ore, ore calcining, and so on. Then, whereas dry, you have a lot of dry conversions like crude oil, food, and again that products, and of course many other. I don't want to read of these. So the next process is the curing and the forming, and of course the other heating processes. And these heat processes require energy. The different temperatures. We have listed out this temperature. This temperature can go maximum of 260 degrees Celsius. These 260 degrees can be attained by the solar energy and can be utilized wherever it is needed. And in this different uh, process heats, process heat industries. That includes here dairy industry, food, textile industry, paper industry, chemical industries, meat, and beverages, flora, fruits and byproducts and timber byproducts, brick and brick plasters. There are wide ranges of process heats where we can use electricity heat. So that if you do it with solar, then it's important. What is a typical process heating looks like that? This is the thermal process heating plant. Before that, we need to burn coal as well as the air in order to gather the needs of the process heat applications. So it's essentially consists of a box which we call heat containment, in which the fuel and electricity are supplied as an energy source, and of course apart from that the material can also be supplied here. And due to this material it gets transformed into various other forms because of the process heat applications. Because materials mainly any form of material. So therefore, we invest in treatments and all those things. So we can use oil and maybe other forms of products. But it's typically there's heat generation, heat transfer, and the heat recovery, and of course the rest need to be emitted. But these emissions are creating a problem, and every level you have energy conservation and energy management. So therefore, if you replace this part of the energy requirement by renewable energy, and of course, it becomes a solar process heat and power generation. And the typical process heat system looks like this here. We have a boiler which air is supplied. Air is supplied here, and then fuel is fed here, and then it goes into the. See here, you see that the combustion air comes in and then picks up and then goes into this one, and then it comes down here power heat exchanger, power generation heat exchanger, and then process heat exchanger. So ultimately it's a process we can tap it at various locations and utilize for the process heat applications. So this is a typical, but here the fossil fuels are used here. This is a simple boiler here, but instead if you replace this boiler solar system, then it's a solar processing system. And apart from that, the thermal power plants, as you know that this electricity, whatever we get is from thermal power plants where the coal is burned and then the coal is emitting the pollutants. But apart from that, it also convert the energy, and that energy can be produced here in this building, and by burning of fossil fuels and running turbine here. And once it produces electricity, it needs to be set down because otherwise the losses will be substantial. And then with different stages of 5 or 6 stages, and ultimately you get about the electricity here with a certain voltage and frequency. See, as far as India is concerned, it's 230 volts and 50 hertz frequency. So this power generating system is not so simple as this box, but it consists of a heat engine. It is in this heat engine operates from high temperature to low temperature through which the work is produced, and of course it takes heat from the source and converts into heat work and then subsequently rejected into the same. So therefore, a thermodynamic cycle, which we call heat engine, operates from high source to low source and then produce high quality energy. But the problem is there are some positive environmental issues. So how it is done is a typical four component Rankine cycle system is shown here: turbine, cooling tower, pump, and boiler. And they are here you can burn fuels. You can burn the fossil fuel like coal, but this gives the pollution which we have already discussed. If we if this acts as a heat engine and this heat is applied with a orange boiler and it evaporates water and water is expanded in a turbine and then from the turbine produces electricity and which is current power to the turbine generator. Obviously, it rejects the heat to the coolant tower. The typical PhD diagram looks like this. Some of your mechanical engineers and some are most of the engineering students they must have studied mm, thermodynamics. In that thermodynamic cycle, you can see that the efficiency of this cycle is given by this uh, the the work produced to the heat supply. Heat supplied is the source, and the work produced is your and the turbine or the transmission lines. So the power plant is not so simple as this, but it involves very complex system like this. And if you look at so chemical power plants in most of in India, so there are so chemical power plants, and they are operated with the coal firing. And here you can see it's a boiler here, and these are the turbines, and this is a cooling tower. I'm not going to. So therefore, the coal is supplied here through the bunkers, and then pulverized, and then air is supplied from here, and then coal and air are used here to generate the heat, and coal is burnt or oxidized by in the presence of air. So this is what a typical. But it's important to look at the various components. This is if you look at that, this is the boiler. This boiler, if it is replaced by a solar system, it's become solar concentrating solar. So we have to improve the energy efficiency by replacing the solar system. So therefore, how do we do that? How do we shift? Then we need to look at the solar energy characteristics. These solar energy characteristics are is a renewable energy, which we call them as environment to environment energy. This system, solar energy rays are coming from the outer space and falling onto the ground earth surface. But if you use them, you can produce electricity. If you don't use them, they are simply absorbed and send them back, reflected. So therefore, it is energy to environment system. But what happens is you need to have a device which can convert this this kind of radiation into utility form of electricity. So if you look at the classification and quantities that are available in the form of environmental energy is about solar radiation which is coming from the sun is equivalent to 1.2 into 10 to the power of 17 watts, and out of which some uh, almost one third is getting reflected back to the space, and remaining coming and it is utilized for human survival and human requirements. So therefore, if you look at the complete globe, and there's a very good reasonable areas where we can successfully demonstrate the solar power plant. So here you can see the solar direct radiation above 5 kilowatt hours, more than 5 kilowatt hours of energy that is available for meter square of area in a day. And if you look at the India, most of the Indian continent, subcontinent is within that region. So therefore, we have a very abundant potential for solar energy. So therefore, we can make use of this solar energy for our benefit. So how do we utilize them? The solar energy technologies, because we are talking about energy conservation management. Then the solar, how do we utilize this energy? How can we treat this uh, energy conservation device or conservation source? So the solar energy can be directly converted into direct conversion like this, and indirect conversion is like this, and water, wind, biomass, and other ocean energies. The other side we have the solar thermal and photovoltaics. In solar thermal, we have a process heat which I have mentioned. There are wide ranges of applications uh, like dairy industry, cattle industry. In fact, we are working with the dairy industries in here. How to fit solar energy systems into these dairy industries is a very important process. Textile industry, tanneries, like leather industries, how do we implement that is part of our activity. So that's a process heat application. Otherwise, we can also utilize this for electricity generation, but the electricity generation depends on how it's everywhere it's cheaper and available in the form of photovoltaic. So thermal route looks to be a bit expensive nowadays. So therefore, but the process heat application is the most attractive options for conversion of these. So energy process heat power generation. If I have already mentioned that they hello hello. Can you hear me?
Yes, sir, you are audible. You may continue,
Yeah.
sir.
Because I got a sound in between, so therefore I thought I am lost. Okay. So this process heat is between 60 to 260 degrees Celsius, which covers wide ranges of applications like hot water system, drying of foods, cooking, desalination, refrigeration, and greenhouses. This energy, because when we go for solar process heat, obviously we are conserving energy. We are talking, suppose if you use a hot water system on the rooftop of your home, obviously you are reducing the electricity bill. Then another side, how the process heat looks is solar collectors converts solar energy into heat, and that can be used to supply the thermal loads in the form of home heat or hot water or industrial processing, etc. But it requires a storage and also it requires auxiliary energy. Storage is in the form of thermal energy storage in this case. But if you look at that power generation based on the temperature, we can classify them as a low temperature, medium temperature, and high temperature systems. If it is less than 100, it's low temperature. Between 100 and 400, it's medium temperature, and high temperature is greater than 400. And the difference between the power generation and process heat, we have an extra element here that is a power law. So this power cycle is playing a role. Otherwise, we can use it this heat directly for them. But we are also working on trigeneration, cogeneration. After producing electricity, still some part of the heat can be utilized. So, what is solar power generation? As I mentioned earlier here, that so it is a Rankine heat cycle. Then this Rankine cycle is powered by the solar heat and it produces electricity. This is a low temperature solar power plant. It is mainly when you go for low temperature power solar plant, we have to go for organic cycles where organic working fluid is used. The organic means refrigerants where these fluids get evaporated at low temperature so that it becomes the steam or vapor and that can be utilized to run these turbines. So therefore, this is one of the processing applications. This can also be used for energy storage. When we have more energy during the daytime, we can store it, and whenever we need it, we can transport like this. Now we are talking about 16 hours to 20 hours of. This is only as an extended storage, but there can be 16 hours to 20 hours of energy storage. A typical energy storage, how best power plant looks like. So we have two tanks system, hot and cold, and eventually it is applied to the boiler and the turbine so that the electricity is produced. So if you go for high temperature, then what is high temperature means we have to go for the parabolic or the concentrating collectors like this, and that is used to evaporate the steam, and not only evaporate but also used for separations of these different fluids. So apart from that, we can also go for auxiliary heating. This means the sun is available only during the daytime. Nighttime, how do we use it? So therefore, this can be achieved by going for auxiliary systems like this. You can go use coal so that the overall coal consumption reduces, and if oil, so that overall oil consumption reduces. So therefore, it's important to come up with a hybrid mode power plants with solar as well as the other fuels like biomass and some other fuels and so on. So then, apart from that, one added advantage with the solar thermal power plants is heat concentrating for solar power plants is that not only electricity but also heat can also be used in this. So therefore, this is a typical process heat and cogeneration system which produces electricity, not only electricity but also process heat. So therefore, there is a single boiler which takes care of both process heat as well as the power generation. And typical TS diagrams look like that. So here we have here essentially 1, 2, 3 points are at the same time to pictorially, but whereas if you look at this, it looks like a apartment. So one of the process heat is a pool heating. You know that swimming pool nowadays, if you look at community houses like apartments and all these, you know, every bigger apartments uh, are associated with a clubhouse, which involves swimming pools and stuff. Especially these swimming pools are not in operation during the winter because the winter ambient temperatures are much lower. So therefore, we cannot venture into the swimming pool. So therefore, it is important to preheat the swimming pool. Preheat means to see the water. See the swimming pool temperature should be delta P of 5 degrees higher than that of the atmospheric temperature. So therefore, this 5 degrees is a very small temperature rise, but it requires huge amount of energy. This energy can be catered with the solar energy. So therefore, the swimming pool can be used like this. You can see here like that. So you put a solar panels here and then produce the heat and then supply to the swimming pool so that we can make it operational in winter conditions also. So this is one of the process heat because here the amount of heat is larger because the volume of water is much larger, but the temperature requirement is very small. You need a huge volume, huge mass, but little temperature. This can be attained like this by a process heat applications through energy conservation. High temperature solar process heat. This is a low temperature because the temperature range is very small. When we go for higher temperature, obviously we have to go for further different concentrations. This is another process heat is like air conditioning system where a lot of energy conservation is required in this air conditioning systems. Why? Because low grade heat can be utilized to produce cold because we are the tropical and subtropical countries are basically suffered by these cooling mechanisms because we need to because we require cooling. So therefore, cooling everywhere because temperatures are higher, so tropical and subtropical conditions. So I like India. So we can go for solar energy process systems like this, and there are different process heaters can be connected parallelly here, and there can be process heat load can be connected with auxiliary heating, but still it is done by solar photovoltaic systems. This can also be used solar thermal systems. This can also be used with the conventional boilers also integrated with that, and there are various process heaters which can be coupled to form a network, grid network. So therefore, the possibilities of combination of solar system with existing heat supply can be utilized. And as a part of that, as I mentioned, that various technologies that are developed at IIT Madras. Here, I am listing out about 20 technologies as far as the process heat is concerned, mainly energy conservation and energy management is concerned. These are 20 technologies. I will give you one by one later when we proceed to these technologies. And this is it is our lab. Our approach is 4D approach: design, development, demonstration, and deployment approach, where we start with a test tube to technology development to 4E approach: energy, exergy, environment, and economic analysis. This is my lab here, and these are my students, and you can see that this is the facility which we have. So. Uh, these we are, as I mentioned, our approach is 4D. So therefore, most of these systems are demonstration scales systems. And here you can see the another view of that. It's a solar dish, which is about 20 square meters area and with 50 kilowatt heat output and which can achieve 640 degrees Celsius and with a 67% efficiency. And if we also photovoltaic tracking, we developed a new tracking system because the photovoltaic energy cannot be uh, increased or the efficiency cannot be increased on its own. So when you track it, then you'll get more energy. Then we have a desalination system. Then we have a parabolic trough collector systems, and then we have conventional concentrating photovoltaic system. Then you can see the desalination is 15 to 25 meters per kgs per meter cube of meter square per day of energy. Then we have this can be about 40 to 60% efficiency. Then parabolic troughs are about 62% efficiency with 8 kilowatt and 350 degrees Celsius. The other side is a concentrating cogeneration system which produce both electricity and electricity of 725 watts and heat of this cogeneration system. We can see that. And if you look at the another view of that, this looks. This is the facilities where you can see that there is a person standing. We can see how they are massive systems, and they are full-scale systems which can be taken to the field. And we have some industrial associates. We have given license of these projects, and then some of these industries have taken this forward, and then they are developing and installing. If you look at the another view, you can see them. It's a parabolic dish, which is a point focusing system, which tracks the sun continuously, and then the solar energy is reflected back into the receiver here. And you see just now the parabolic graph and the desalination, solar flat rate collectors, and ETC and TIM ICS systems, and so on. So you can see that here, and then we are associated with some industries. They have installed in their industrial locations. This is one which is installed in Hyderabad, pharmaceutical industry, and this is locally installed here. And see, again, producing heat and energy is can also be done through hydrogen, because India is looking for green hydrogen now, and there's a even big companies like Reliance are participating in this producing green hydrogen concept. So therefore, this green hydrogen is a separation, splitting of feedstocks. Either it could be water or it could be methane, and water is split into hydrogen and oxygen, and methane is split into carbon and hydrogen. And this is the reactor which we developed at IIT Madras, and we modeled it to produce hydrogen here. And this is a typical system here. And this is the water, the solar concentration goes into that, and it comes out as a feedstock. This is one which we have. You can see that it's installed our technology mainly for pharmaceutical industry here. This is a, as I mentioned, my talk is on energy consumption and through development of solar energy for energy efficiency and management. So here, this pharmaceutical industry is the electricity is replaced by its director, so that the collector only can give you the required output or as per the requirement. We cannot keep this is idle. So if you look at that, it's the specifications here. The solar energy which is coming from here gets concentrated onto the receiver, and this is about 85 square meter area in the aperture, and it produces about 660.5 kilowatts and the 220 kilowatt electricity. This is a plant which we have at IIT Madras. We installed in our laboratory, and this is this is the actual process heater. So we have a process heat application for that. It's 1.5 meters width aperture, and this is 2.5 meters width aperture, and so on. So this is we have installed this on fourth floor of our classroom complex, and you can see that this is a process heater, and this is another process heater which can be used and tested even for others. We installed a comprehensive dry generation system at school, which is close to Chennai, about 70 kilometers. The school name is the Patashara campus, and that is in Vallabh. So therefore, here the school students requirement, about 150 students requirement of electricity, heat, and other things that we made. And this also has energy storage here, and with this with the 50 bar pressure and for 350 to 400 degrees Celsius temperature can be utilized in this, and the complete design and development instrumentation labs capacity was studied by us and then implemented, and development of heat transfer model and analyzing and optimizing the characters are there. And we can also do indoor experiments. Um, these indoor experiments are, because it's very difficult to do experiments in real time, because real time the sun keeps on moving. But by both the readings also very important to standardize the equipment. So therefore, we are working on two-phase flow simulation studies for solar parametric LFR receivers. But similar way we can use distribution by lights here. You can see these lights are there. So these lights focus onto the receiver here. That concentrates here, but these lights, each light will represent the solar energy profiles, and accordingly we can do that. And again, we this linear solar reflector system we install in industry landscape Coimbatore, and it produces. You see that the steam here. So the water, this is a linear solar reflector. The water enters from here and moves into this direction here till here, and then take a U-turn and come back, and then is released here. You can see superheated steam, how intense it is, how intense this superheated steam is. So we have an air conditioning system here, and also big dishes here. These are big dishes. These dishes are concentrating solar energy, and they require two axis tracking to track the sun. And solar energy comes from the sun and gets reflected here. And it's a massive system which is placed on rooftop of heat transfer lab. So these this concentrate, this is square dish and this is circular dish. And the temperature here we get about 1500 degrees Celsius, here about 800 900 degrees Celsius, and this is the boiler where the solar energy is converted into heat. And so therefore this heat can be used for this air conditioner here. It's a first of its kind in India, because a small window type of air conditioner can be done with the solar energy and so on. Can be powered with the solar energy. And so therefore, this is the first of its kind of window. There are about close to 3 tons of air conditioning system. This is a vapor absorption air conditioning system. So therefore, a lot of waste heat recovery, energy management, energy conservation can be done. So there's another important process here, like a hot water system. As I mentioned, in process hot water, the conventional hot water systems are they're expensive, and then the efficiency, because storage and collection are in separate units. in this particular system, the collection and storage are in the same unit. That's why we call integrated collector storage systems. And it replaces the commercial flat plate collector or evacuated tubular collector. It's a tube insulation based transparent insulation material for parabolic for performance improvement of the solar thermal power systems and so on. So this is a typical structure here we can see here, and this is a so photovoltaic panels, and we have tracked with these single axis tracking, which track the sun, track the panel from east to west, and so that is a very simple and which can give more energy during the daytime, and which is more than it's a passive system. You with the counterweights you can see that this is and if you look at closely, it looks like this here. There's a mechanism which takes care of the tracking, and we get an additional energy here. And apart from that, we can also concentrate solar energy onto the receiver, where the photovoltaic panels can be placed so that we can obtain cogeneration or trigeneration. And here, cogeneration is producing two products like electricity and heat, or sometimes electricity and heat and water. We can use anything depending upon cogeneration concept or trigeneration concept. This is a lens-based system where the cells are placed here, and this is a triple junction solar cell. Here it's these solar cell, triple junction solar cell converts solar energy about 30 to 40% here, and this 30-40% conversion is a substantial as far as, because it's a tandem solar cell, triple junction solar cell. These cells are placed here in a refractive lenses, because it refracts solar energy onto the earth surface, and so therefore it's important to again track. See, this consists of two axis tracking. One is this azimuth, and the other one is the elevation, and this is the secondary concentrator which needs to be placed in this hotspots. So another important thing is these concentrators for mainly another process heat application. Here is you can see that it's desalination. For desalination, we developed a process heat system connected with hyperbolic profile and electrical aperture, and this can be integrated with the desalination system. And it's a passive system; it works throughout the day without much disturbance. So therefore, without tracking, we can use it for low temperature applications. I strongly advocate this non-concentrating collectors for process heat application. If you go for high temperature, we can go for tracking type of system. We have developed like that. You can see here the receivers and other things, and we do optical analysis here and then subsequently use. Then another one is desalination. Is a multi-trade desalination where the collectors are used to produce vacuum, and that is low pressure, as well as the producing the evaporation condensation in the same units. And waste heat recovery is another concept here in this, and it is developed like this. You can see here, and based on this, this is the solar energy comes here, gets absorbed, and then it takes into this, and then evaporation is done. Water evaporates, and at the bottommost surface it condenses, so that the water can be taken out and used. And this is a simple system. It involves simple component, but of course it's a waste heat recovery system, and whose efficiency is very high. Even you can see that output of 15 to 25 liters per day per meter cube of area, sorry, for a meter square meter of area, and so on. So we can use for different stages, and which each stage will have its own output, because it's a cascade system. Then we have to find out what are the maximum number of stages, and we can also use not only producing water from the brackish water. It can also be used for seawater or even other types of water, saline waters, and so on. It works very well for others. And this is another vertical type of solar strip, where both the sides are used to capture energy, and the overall yield is much better as compared to the normal cases. And this 4 meter square area can produce 21 liters of this one, and year-round performance throughout the year will also give you a better, like from January to December can give you overall yield better there. And so therefore it's important for especially low cost solutions here. And apart from that, the human waste is because solar energy can be used not only for producing water but also can be used for treating wastewater as well as the other water. So we developed a system, uh, wastewater still and wastewater system here. So this wastewater system is here. We put the wastewater into these and then evaporate and condenses here, and it's that. The another one is human waste. In conversion of human waste into fertilizer, we use solar system human waste, and because we want to develop a direct system. So again, as I mentioned, that the textile effluent treatment, we based on the solar energy can be used as a energy management and waste energy conservation method. We did it in IIT Madras, and it demonstrated in one of those textile companies in Tirupur. You can see that this is the one. And another important thing is an energy efficiency. Building sector is an important thing where we need to conserve energy, because that's what we tell the people, that to switch off the lights when you don't need it. So net zero energy buildings are very important. We are developing net zero energy buildings through renewable energy integration and also waste management techniques. So this is this conceptual view where the top is covered with photovoltaic panels, and these turbines, vertical wind turbines are placed here, and these wind turbines and PV can power the entire house. And apart from that, there is a waste which comes out can also be treated and reused. And this is another view of affordable net zero energy, and it's a flexible. Affordable means you can see that their beats are there, they are collapsible, and then we can change the orientation, we can use it, and so it's completely flexible and affordable, because the materials are used very inexpensive materials and cheap or low cost materials, and so therefore the overall cost becomes low and it becomes affordable, and it can be used, assembled and disassembled easily and taken to any area and so on. And as a part of our just now I told you toilet, we developed a zero discharge toilet installed in one of our students' hostel, and it is working. It's hermetically sealed completely. The solid is converted to biomass, and the liquid is treated and recirculated in this. So this is another important. We have license to some company here. And apart from that, this integrated renewable energy system plays an important role here. This integrated renewable energy system is combining hybrid wind, biomass, and the solar, which can also substantially improve the energy efficiency of conventional power plants. So therefore, this is a comprehensive system with the solar, hydrogen production, and the anaerobization of biomass here. And you see that the panels are placed here. This anaerobization comes as a gas into this engine. And this engine has been modified by the students and subsequently used to power the grid here. The people power the grid. This is a control system and then energy storage here. We developed, demonstrated here in IIT. Before installing that, we installed here with the hybrid control system, batteries, and then biogas here and so on. This is a design and development of grid. Here with the grid connection also, because we can connect to the grid. So in the previous slides you have seen here, there is no grid here, and this is a tribal village where we can do that. So then another thing is, another important is automobile. You can see a lot of fuel efficiency. We are talking about electric vehicles. Electric vehicles are coming in a big way, and that keeps the energy environment more sustainable. And not only that, we have cleaner energy solutions and so on. So therefore, it's a simple system with the PV on the rooftop, and then development of this, powering this, put it there, charging, recharging, and it looks like this. These are the specifications of
specifications of solar panels and engines, this motors, battery bank, and other things here you can see here, and they are all fitted, assembled, and then the PV panel charges the battery and subsequently used wherever it's required. A typical system looks like this. Here you can see we modeled in the beginning, and then how to charge, discharge, and what are the different execution strategies or protocols for operating this system here. And here you can see that's how it's published in paper. If you want this, see these are assembled with bringing all different materials here and here and then making into units. We have also done structural analysis for this in order to keep, because this is a moving system, so therefore there's a possibility of air drag, and that may influence the overall consumption of battery and other things. So therefore we have completely analyzed in terms of safety and compared with the conventional auto. So, and it proves that it's very good option, and viability also plays an role in this. And my students, when they are testing this, the load test and road test, road test and load test, or load test and road test. So we need to go for load test. Load means how many people are sitting there and how long it take it, and what is the torque levels and the load test. But road test means road terrain is also important, whether the terrain is good or uphill, or most of the Indian roads have a problem of this one. So therefore, under rough roads, how it behaves, under good roads, how it will behave, that is done here. And you can see that it's compared here, and this is a comprehensive this one, and the overall economics how works out to be better in this case. So therefore, it is important to look at that here the cost benefit thing, and the payback period is somewhere close to 3.4 years, and which is good, and the gains is about 15.7% higher than that. You can look at these configurations like the solar panels and how rated output is achieved and so on. The other parameters based on the overall costing, you can see that what is the inflation rate, discounted capital cost, and so on. So this is an important idea to conserve energy through these electric vehicles. So because it has the advantage that zero greenhouse gas emissions, reduction in energy cost, and less noisy, and of course unlimited of solar energy is available. We can use it whenever it is needed. So with this, I have given some of those concepts in process industries, energy efficiency. So our approach is the development of energy efficiency in the process industries. If you look at sector-wise, coal, oil, large scale, this thing is there. So 4E analysis is another important approach for solar process heat applications. The 4E is energy, exergy, environment, and economic analysis, which is meant for energy conservation and management. This can be done through 4E analysis here. This involves various power generating plants like combustion-based, gasification-based plant, hybrid power plants, and optimization of these power plants, and so on. So therefore, exergy here is different from energy, and there is exergy and energy. Exergy is equal to energy minus energy, that is the losses, and this gives us a kind of parameter. It says the quality of energy rather than the quantity of energy. So therefore, exergy is the maximum work obtained from the system coming to equilibrium with the surroundings, and this higher value of exergy means more work obtainable with system. The first law of thermodynamics says that only first law tells that the transformation of energy, whereas second law tells the quality of energy. So first law tells the quantity of energy, second law tells the quality of energy. So therefore, if you do it holistic, analysis of both energy and exergy analysis are important. I'll give you some of these parameters here. The effectiveness and the factors influencing the inefficiencies, are the causes of inefficiencies include loss of energies like mechanical energy, friction, impacts, and dampings, and fluid friction is losses, fluid leakages, flow restrictions, and for fouling and other things. Heat transfer is convection, conduction, radiation are the play. Electrical losses efficiencies are resistance, heating, and eddy current losses, and the current is discharge, line losses, various other things are there which are required for improving the energy management and so on. And losses of availability through combustion, pressure drops, and temperature drops. These are the where the energy efficiency plays a major role, or the energy conservation plays a major role here. These are some of the equations which I am not going in detail. This is the second law analysis, and based on the second law analysis, we can come up with the overall analysis at component level, how the energy is distributed and how to conserve this energy and so on. And that is what in terms of the availability work, and which is in terms of reliability, reversibility and irreversibility. See, the work which cannot be reversed, so therefore it becomes a useless, and this irreversibility plays a major role in all these energy industries, mainly process industries also. So therefore the significance of exergy is very important here, because it tells us the maximum available work and how the energy is being lost, and how we can conserve energy. These are the super important things. Energy is always conserved, and what not is conserved is the exergy. That is useful work potential of the energy is called exergy. And once the exergy is wasted, it can never be recovered. So one important thing is improved energy resources utilization can be realized by reducing the exergy destruction within system, and also reduce the losses is important. So therefore, it's an important an objective in exergy analysis is to identify the sites where the exergy destruction or losses occurred, and we have to categorize rank them to know the significance of these. Allow attention to centered on aspects of system operations that offer the greatest opportunity for cost competitiveness, cost effectiveness, and of course improvement the cost effectiveness and so on. So a typical racking cycle looks like that. So there is a huge thermodynamic analysis. I don't want to discuss this. And based on this second law analysis, how the vapor cycles are operated, the methodologies, there are governing equations which plays an influence, and then we have to look at the techno-environment-economic analysis for large-scale solar thermal commercialization system, because process I mentioned that dairy industry is one of the industrial process heat. The national about 32% of national energy consumption is in the form of process heat, and 74% of this energy is consumed in industrial process heat. So therefore, India has the highest level of milk production, and so therefore we are largest producer of milk, and also largest consumer of the milk also. So therefore, solar energy can be used in this industries in commercialization for this. And we have done a thermodynamic analysis, mainly industries, how fluid can be implemented and used, and the thermodynamics. Same here, we have identified the irreversibilities and come up with a thermodynamic analysis, and identified how we can reduce this and so on. These are some of the characteristics of that, with the exergy loss and energy loss, and then thermodynamic analysis results. And so we can also use industrial process heat to this by solar energy, so that we can save the energy, we can conserve the energy. And we have seen this particular process heat implemented here, a lot of data generated, and how much we can use that, and what extent we can use is an important thing. So emissions and economic analysis also play a major role. These are sustainable, less polluting, less emissions, and of course more attractive in terms of economics. There are emissions we can see here. These are you can see that with in terms of economics and emissions. And overall, it seems to be better in this case for process heat application. We have developed an atlas complete entire India with west, east, and north, and central, and of course northeast, with different areas like Gandhinagar, Chandigarh, Lucknow, Chennai, Kolkata, and Shillong is being considered for this. So if you come up with the concluding remarks, I think I'll give you some time for interaction.
So exergetic and thermal efficiency of a whole solar and partial radiation system is very good, and it's in the order of 50 to 60% efficiency. With the storage, storage can be one of the good attractive option, or we can go for auxiliary energy systems which can save better. And this system can mitigate so many tons of carbon dioxide, methane, and nitrous N2O, and so therefore very important. And the investment is in the order of 5 to 8 crores. And to support this, and the levelized cost of energy delivered will be this for every key gigajoules of that. So the discounted payback period ranges from 4 years to 12 years. Whatever money we invest, will get back. With government subsidies, it can even come better. So with this, I end my talk, and I'll give you interactions. So thank you very much. And if you have any questions, please feel free to ask. I think we have some time to discuss. Okay, thank you very much. If you have any questions related to solar energy or energy efficiency or energy conservation, thank you very much.
Thank you, sir. I invite the participants. If you have got any questions to be asked, you may either post it or you may unmute yourself and or ask Srinivasan sir directly. Please come up with your questions.
Sound is not clear.
I invite participants to pose your questions. Yes, Santosh Vyas says sound is not clear. I hope now it is clear.
Okay, if there are, I don't think anything is there in the chat box, or any questions are there?
No, sir. No questions in chat box.
Okay, ठीक है. If there are no questions, I think participants are hungry, so it's a lunch time.
You rightly guessed.
What is the scope for integrated renewable energy system? There is a, because the integrated renewable energy system means now integrating the two renewable energy systems. Like now most of the large scale like Tata Power and all, they are working on this also. So the scope means whenever there is a solar, then you can utilize, and when you have a wind, we can have wind, so that we can hybridize. This integrated means two sources are integrated. So there is a huge potential for that, because mainly the problem with solar energy is night time it's not available. If the wind is available during the night time, that can be used. So therefore there is a huge, we can integrate both of them and use it for the required load conditions. So there is a huge potential. If somebody is interested to work on that, still can work on that. If you have any specific questions, please let me know.
Any more questions, participants? We can wait if you have got any more questions to be asked.
No problem. You take your own time. There's no issue. You can also speak if you wish to speak.
Yes, sir.
Unmute your mics and speak.
Yes, sir.
One advantage with the online is even while you can do other activities, and because live you can take lunch family and attend the. But I think maybe everybody is hungry.
Okay, thank you, Dr. K. Srinivas Reddy, sir. On behalf of the Institute, the organizing team, and the participants, I extend my heartfelt gratitude to our expert speaker, Dr. K. Srinivas Reddy, sir, for accepting our invitation to be our expert speaker. I thank you, sir, for taking time out of your busy schedule and obliging.
Thank
Sir
you.
has sir has really touched upon a lot of areas like global energy, potential data worldwide, types of energy, tidal wave. He also gave very good information regarding energy demand and prosperity, global energy poverty, and also about energy sustainability and security aspects. The technology challenge he gave information was quite very nice. Very energy reserves about coal, oil, gas, global scenario, what is happening at global level. He also talked about process heat and power generation, industrial process heating, thermal power details, solar energy power generations, solar energy for process heating, etc. Solar research facilities developed at IIT Madras. He gave so much of photographs also, and many other installations were shown. He also gave information about design and development of cavity receivers, also of the solar thermal power plants. Dr. Srinivas sir has really done a lot of extensive work, installation, R&D, and pioneering work at IIT Madras. Lastly, he also gave information regarding stills, solar power plant, solar power auto rickshaws for wastewater treatment, net zero building, etc., etc. He has got lot many questions, and I'm damn sure a lot of people would have been influenced and motivated and enlightened to find and do more research work and to take help from Srinivas sir. We are also proud of you, sir, to have given us glimpse of most of your works and also about concepts. Lastly, you spoke about concepts of energy and exergy. So once again, on behalf of all the participants and organizing team, I take this opportunity to express my sincere gratitude and thanks to Srinivas. Thank you, sir. Thank you, sir. Thanks a lot.
Thank you. Thank you very much. All the best for the rest of the program. I wish you all the best. And I'm signing off. Thank you.
Thank you, sir. Thanks a lot.